So 18.0 notes, special right triangles. This should be review from IM2 for you. Is it? You did this back then. All right, so we have two types of special right triangles. By the way, they are right triangles. So all of your SOHCAHTOA stuff still works. All of your Pythagorean theorem stuff still works. But if you remember that they're 45, 45, 90, or 30, 60, 90 triangles, and remember these shortcuts, it can save you a lot of time when you're trying to solve things. So, I'm going to start with the 45, 45, 90 triangles. And this right here is really a picture of what you need to know about them. In a 45, 45, 90 triangle, hopefully it's understood that the angles measure 45 degrees, and 90 degrees. Duh. Also, if I have a triangle that has two angles that are the same measure, what type of triangle does that make it? Isosceles. So if the two angles are the same, we have two sides that are also the same measure because it's an isosceles triangle. Those sides are called what? In a right triangle, the sides that are not the hypotenuse are called legs. So in a 45, 45, 90 triangle, those two legs are congruent, meaning they are the same length. The hypotenuse is equal to the length of a leg times radical 2. And that's what you need to remember about a 45, 45, 90. Does that make sense? So these are some ways that a 45, 45, 90 triangle could be drawn. This is an example of something that's not necessarily a 45, 45, 90. But this right here, how do I know this is a 45, 45, 90 triangle? These lines right here mean what? That those two sides are congruent. If I have two congruent sides in a right triangle, it has to be a 45, 45, 90. Automatically. This one right here is a 45, 45, 90. Why? Because if I subtract those two things from 180, I'm left with 90 degrees for that third angle. This one is a 45, 45, 90. Same reason. If I subtracted those two angles from 180, that last angle makes the other 45 degrees. And how do I know that this is a 45, 45, 90? If I have two congruent angles, that's another reason or another indicator that I have an isosceles triangle. That means that this side right here, opposite that angle, is going to be congruent to that side right there, opposite the other congruent angle. And if those two are the same, we have our 45, 45, 90. Okay? So. Now, I'm going to go through these problems and do all the 45, 45, 90s, and then we'll come back and talk about 30, 60, 90s. So, is this a 45, 45, 90 triangle? Yes. How do you know? Because if this is 90 degrees, that leaves me 90 degrees for these two angles, and if they have to be the exact same measure, they have to be 45 degrees each. So I have a 45, 45, 90. They have given me the hypotenuse of the triangle. If the hypotenuse is 10 radical 2, and I know that a length of a leg is equal to something that you... Let me try and explain that a little bit better. The length of the leg times radical 2 equals the hypotenuse. What is the length of the leg here? 10. So both legs here are equal to 10. Easy example, right? Okay. Is this a 45, 45, 90? No. Is this a 45, 45, 90? No. Is this a 45, 45, 90? Yes. Because I have 45 degrees, that leaves me 90 degrees for right there. Now, this one is the same type of problem, but it's a little bit trickier because, yes, they're giving me the hypotenuse, but there's no radical 2, so I can't just take off that radical 2 to find the legs, can I? So let's think about this for a minute. If I were to label this side X, what would this side be? Also X, correct? And what do I know about the relationship of the sides? I know that if you take the length of a leg, which I'm calling X, and I multiply it by radical 2, what does that give me? the hypotenuse, which in this case is 10. Does that make sense? So how can I find the length of the leg, or x? Divide by radical 2. So x is equal to 10 over radical 2. Now there's a little problem with that answer. What's the problem with that answer? Can't have a radical in the denominator. So how do I get rid of it? Multiply by radical 2 over radical 2. What does that give me? 10 radical 2 over radical 4, which is 2. Can I simplify it any further? By the way, when you are multiplying, I didn't say this, but you can multiply a number that's not in a radical by any other number not in a radical. You can multiply numbers inside a radical with other numbers inside a radical. You cannot multiply numbers inside a radical with numbers outside a radical. They have to stay either inside to inside, outside to outside. Same thing with reducing. I cannot reduce these two 2's because one is inside a radical, one is not. But what can I reduce? The 10 and the 2. So what is that going to give me? 5 radical 2. So the lengths of each of those two sides is 5 radical 2. So? Good answer. All right. Is this a 45, 45, 90? Yes or no? Yes. How do I know? Those sides are congruent, which makes it an isosceles right triangle, which is always going to be a 45, 45, 90. Now, I notice they give me a measurement that is a decimal. What does that mean? That means that I can give a decimal as my answer, right? So they're telling me this is 5.7 inches. What's this side right here? Also 5.7 inches, right? And how would I find the hypotenuse then? I would take 5.7 inches and multiply it by what? Radical 2. And I'm going to do that on my calculator. 5.7 radical 2. No, it's hard to see from the glare. I get 8.06, so what should I round that off to? 8.1 what? Inches. So? Is this a 45, 45, 90? No. Is this a 45, 45, 90? Yes. Yes, it says so in the problem, so let's answer it. This one is not a 45, 45, 90, so this is the last one of these types of problems that I have to do. Now, it says do radical 6, and 2 radical 3 form a 45, 45, 90 triangle. Well, they're giving me two measurements that are the same, so I can assume that those measurements are the legs, correct? If this is a 45, 45, 90 triangle, then the measurement of a leg times radical 2 will be equal to what? The measurement of the hypotenuse. Right? If this is a 45, 45, 90 triangle, then the measurement of a leg times radical 2 will equal the hypotenuse. If this statement that I have written right here is true, then yes, I have a 45, 45, 90 triangle. If it is not true, then no, I don't have a 45, 45, 90. So, what is radical 6 times radical 2? Radical 12. Again, inside times inside is inside. Can I draw a tree for radical 12? 6 and 2. 3 and 2. What comes out of the radical? The 2's become a 2 outside, and what's left inside? Is that what I needed it to equal? So is it a 45, 45, 90 triangle? Yes. So? Okay. Let's look at the bottom two problems. One of these is a 45, 45, 90 triangle. The other one is not. Which one is a 45, 45, 90? The one with the square or the one with the triangle? Square. How do you know? Because what? squares have 90-degree angles. That gives me the right part of the right triangle. And they also have a diagonal that bisects the opposite angles. So if it's cutting this 90-degree angle in half, that means I have 45 degrees, 45 degrees, 45 degrees, and 45 degrees. So I have two 45, 45, 90 triangles. Yes? Okay. What do I need to find in this problem? The perimeter and the area. How do you find the perimeter of a square? Side plus side plus side plus side, right? Since it's a square, all four of those sides are going to be the same length, so I could also find it by doing 4 times the side, right? Because I'm adding the same number 4 times. How do you find the area of a square? Length times width, or base times height, however you say it, but one side times the other side, right? So, what do I know about this triangle? Or about this square? The diagonal is 18 inches, which means this measurement right here is 18 inches. Does that help me find the perimeter or the area? No, because I actually need the length of the sides for that, right? So if I know the diagonal is 18, I actually have a problem just like this one up here, don't I? Where I know the diagonal or the hypotenuse and I need to find the legs. So let's set this up. If I'm calling my sides both side x, I know that the length of a side times radical 2 is equal to the length of the hypotenuse, which in this case is 18. How would I find x? Divide by radical 2. So x equals, now 18 over radical 2 is an issue, isn't it? How do I get that radical 2 off the bottom? Multiply by radical 2 over radical 2. What does that give me? 18 radical 2 over what? 2? What does that simplify to? 9 radical 2. So the length of each side of that square is 9 radical 2. So if I wanted to find the perimeter, I would take 9 radical 2 plus 9 radical 2 plus 9 radical 2 plus 9 radical 2, or I could do 4 times 9 radical 2, right? What does that give me? 9 and 9 are 18, 27, 36. Radical 2 is what I get when I add all those together. So my perimeter is 36 radical 2 what? Inches. That's my perimeter. Okay, questions there?
If you plug that into a calculator with all the 9 radical 2s, would that work?
Good question. If I plugged it into a calculator with all the 9 radical 2s, would it work? Some calculators you can. Many calculators, like these guys, as soon as you plug in a radical, it's going to give you a decimal. So some of them will maintain that radical form. Other ones will go to decimal. So you just got to add the front numbers and then leave the radical. Okay? All right, let's do the area. Area would be what?
1/2 length times height.
Not 1/2 base times height. I'm trying to find the area of the whole square. Okay? So that would be 9 radical 2 times 9 radical 2. 9 radical 2 times 9 radical 2. What does that give me? 9 times 9 is 81. What's radical 2 times radical 2? And 81 times 2 is 162. And how should I label those? Inches squared would be my area. Capiche? All right. Now let's go on to the 30, 60, 90 triangles. So here's everything for a 30, 60, 90 triangle. Now, in a 30, 60, 90 triangle, the first thing you want to get, if it's not given to you, every single time, the first thing you want to get is the short leg. Now, which leg is the short leg? The short leg is the leg that is opposite 30 degrees. 30 degrees is the smaller angle, therefore it has the smaller side opposite it. 60 degrees is the bigger side, so it has a bigger side opposite. 90 degrees is the biggest one, so it always has the longest side opposite it. The hypotenuse is always the longest side. So how is this related? From the short leg. To get the hypotenuse, you double the short leg. So if my short leg is 4, my hypotenuse is 8. To get the long leg, or the side opposite the 60-degree angle, you take the short leg and you multiply it by radical 3. So in my example that I was saying, if my short leg is 4, what's the long leg? 4 radical 3. It is very, very inconvenient to go from the hypotenuse to the long leg or from the long leg to the hypotenuse. You always want to start with the short leg. So if you aren't given the short leg, that's the first thing you want to find. Okay? So, different ways you could have a 30, 60, 90 triangle. These ones should be pretty self-explanatory because you can just subtract them from 180. This is another way you could see a 30, 60, 90 triangle. Whenever you have the short leg and the hypotenuse is double it, that's a 30, 60, 90 triangle. Or when you have an angle, one of the acute angles, and the other angle is double it. Because isn't 60 double 30? Yeah. So those are also ways to represent a 30, 60, 90 triangle. Okay? All right, so let's look at this one. What side have they given me? The short leg, the long leg, or the hypotenuse? The long leg. Now, I can tell that not just because it looks like the long leg, but because they've labeled this as 60 degrees, the long leg is always opposite 60 degrees. So, what side did I say to get first? Short leg. So, if this is 5 radical 3, what's my short leg? 5. Once I have that, it's easy to get my hypotenuse because I just doubled this, making my hypotenuse 10. Questions there? Okay. Is this a 30, 60, 90 triangle? Yes. What have they given me? What side have they given me? The hypotenuse. Again, the first leg I want to get is the short leg. So if they tell me the hypotenuse is 14 radical 2, how do I get the short leg? Cut it in half. Divide it by 2. What does that give me? 7 radical 2 is the short leg. Half of 14 radical 2 is 7 radical 2. Now, how do I go from the short leg to the long leg? Take the short leg and multiply it by what? So what is 7 radical 2 times radical 3? 7 radical 6. Can I draw a tree for 6? I can draw a tree, but is there anything I can take out? No. So that long leg is just 7 radical 6. Questions there? All right, this problem right here, what do you notice about this problem? They're telling me it's a 30, 60 this way, but what else do you notice? It's the exact same problem as the last one. Do you see that? They're giving me a hypotenuse of 14 radical 2. The only difference is this triangle's laying down. So it's the exact same problem. I think we notice that every year and we always forget to change it. So this would be 7 radical 2. This would be 7 radical 6. Same exact problem. Okay? All right. Next one. Do 5, 10, and 10 radical 3 form a 30, 60, 90 triangle? Well, let's think about this. A 30, 60, 90 triangle is going to have a short leg, a long leg, and a hypotenuse. So which one of these measurements, 5, 10, and 10 radical 3, is the shortest measurement? 5. So they're saying that the short leg would be 5. So let's think about this for a minute. If the short leg is 5, what's the hypotenuse? 10. So those two are reasonable. Would the long leg be 10 radical 3? No. What would it be? It would be 5 radical 3. So can these three measurements be a 30, 60, 90 triangle? No. Make sense? Okay. This last problem down here was actually a homework problem. This was number 8 on your homework last night. Find the area of an equilateral triangle with a side of x. What do you know about an equilateral triangle? All sides are equal. So if I call this side x, this side x, this side is also x. What else do you know about an equilateral triangle?
All the angles are the same.
It is also equiangular, meaning that all 3 angles measure the same. So if a triangle has 3 angles that equal 180, and all 3 angles have to be the same, what does that make them? 60 degrees. So this is 60, this is 60, and this one is being bisected, which makes it 30 and 30. Now, I don't want to use trig for this. I don't want to use the area formula we talked about yesterday. I just want to use 1/2 base times height. Because the sine of 60 degrees or the sine of 30 degrees, whichever one we were to use, we don't know how to find easily yet. We will once we get into the unit circle, but we don't know that now. So let's use this so far. So let's see, what is the base of this triangle? X. So I have 1/2 times, I'm going to call it x over 1 just so I can stick with the fraction theme. Is that okay? Now, what line is representing the height in this picture? The dotted line, right? So if I were to look at that dotted line, and I were to look at, I'm going to ignore this part of the triangle right now. If I look at this, this is a 30, 60, 90 triangle, right? And that dotted line is representing what leg? The long leg. What is the length of the short leg here? 1/2 x. Or another way I could say that is x over 2, right? So if I know the short leg is x over 2, how do I find the long leg?
X over 2 to
Multiply it by radical 3. So it would be like x over 2 times radical 3 over 1. You okay with that? That this right here represents the height or the long leg. So since I've written all those as fractions, can I just multiply across the top and multiply across the bottom? So 1 times x times radical 3. What does that give me? X squared radical 3. You may be tempted to say radical 3 x squared. Radicals always, 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 always go at the end of whatever you're saying. Because otherwise it's hard to tell if the x is part of the radical or not, so we just leave it at the end. What do I have on the bottom? 2 times 1 times 2 times 1? 4. That's my expression for representing the area of this triangle. Kind of crazy? That was number 8 on your homework last night. All right, so there's your 45, 45, 90 triangles and your 30, 60, 90 triangles. Your homework is worksheet 18.0A. Happy studying.